Cool. Looks like we're live.
Great. Switching back and forth, so I'm not just going to film you this time. So
All right, that's progress.
Yeah.
So I'm going to go ahead and open up my group meeting quiz.
Okay, that's great.
See if I need to get the SPSS stuff up.
Okay, I need to do the same then.
Yep. All right.
So did you guys end up dressing up?
No, we didn't, unfortunately.
Oh no, that's fine. But, I mean, Halloween's one of my. It's not one of my favorite holidays in the world.
Oh yeah. We just don't have anything to dress up as. Well, to dress up. And I guess
Just tell him you broke your Halloween costume.
My wife won this at work, and
Wait.
the little strap broke. So
nice. Are you guys Star Wars fans?
not. I mean, we like Star Wars. I don't think Sasha's seen them all, but not like huge fans.
Yeah. I mean, not big enough that you would like dress up as like, a stormtrooper.
Although I have always wanted to wear a stormtrooper costume because it looks cool.
It does. It's pretty cool.
Yeah. But maybe next year. We'll see.
Okay.
Yeah, Sasha said we'll have a little family of stormtroopers.
There you go.
Maybe. We'll see. Things work out.
At least one.
Here, see if I can show you what we dressed up as.
Oh, wow. Y'all were truly dressed up as Mexicans. That's impressive.
Told you.
Wow. That's pretty good.
Yeah. Sombreros and everything.
Yeah. It's amazing what you can find at DI.
Yeah. Okay, where did that stuff go? Oh, there it is. Okay, so I think I am ready.
Okay, my quiz is just loading.
Oh, you're fine.
Okay, I'm in.
Nice.
Okay, are you ready for question 3?
Yes, I am.
Okay.
So
I can go ahead. Yeah, go for it.
Right. Perfect. Oh, sorry. Okay. This is the problem with computers. I'll go ahead and read it.
Okay.
In an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate that at least one mean is different from the others.
I believe that's true.
Yeah, I think so as well.
Okay.
On just a second.
Okay.
Am I too loud?
No.
Am I too loud for you, Thomas?
No.
Be louder.
Okay, I think I can still hear you.
Okay. Great.
All right, are we on number 4 then?
Yeah.
Okay.
So what requirements need to be checked when performing an ANOVA hypothesis test?
Okay, I know they have to be normally distributed. And the variances have to be equal. I think that's it, isn't it?
Yeah.
Okay. Just 2 requirements.
Wait a second. So I know that you might be right as well. I know that any of them can be negative, or can they?
You're right. Well, in my notes here, an F distribution is never negative.
Okay, that's what I was remembering.
Okay, yeah. Would that mean the same thing?
I don't know. That's what I'm.
Yeah.
I don't know.
That's
I'm
a
gonna
really
put-
good question.
Yeah, I'm gonna put a check mark there, and if it's wrong, I'll just take it away.
Okay, sounds good. And then to check if each group is normally distributed, do the following.
C?
Yeah.
We assume the variance in each group is the same if the following happens.
Okay, so I'm pretty sure it's B. Less than 4 times the smallest variance.
Yeah, that's what I was thinking as well. So,
Awesome. Okay.
good.
An ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs, 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples? Okay, I didn't follow this one very well.
Wouldn't there just be 4 pairs?
I think you're right. So there's 1, 2, 1, 3, 2, 3,
Actually, there might be more.
3, 4. Oh, and then 1, 4, 2, 4. Maybe 6?
Yeah, there might be 2, and yeah, 1, 2, 3, 4, 5. I got 6. Yeah,
Okay.
sounds like someone's being beat up over there.
The rice cooker is taking a real beating. He said it sounds like someone's getting beaten up over there. All right, now we are using the soccer shoes data. So the data in soccer shoes was collected to help determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes labeled A, B, C, D, E, and also just wearing socks for a total of 6 groups. Each row represents a kick from 10 meters away from a target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target, so smaller numbers are more accurate. Answer the next 5 questions using the scenario above. What is the minimum or smallest variance for the 6 groups?
Okay. All right, well, my SPSS is like taking.
You're fine. So I guess I missed a lot in the reading or in the video. Is the smallest variance, is that going to be after we calculate it through SPSS?
Yeah, I think we just take the square. No. Yeah, we just, after we calculate it through the smallest one. I think that'll just be it. The smallest number.
Yeah. One-way ANOVA.
So we do need to do in code, right?
Yeah, I think for this one we do, but we didn't for the preparation, which was nice.
Yeah, that was nice.
Okay.
I felt like I wasn't very helpful in the last assignment. So today I spent so much time trying to figure step out so I could be helpful.
I disagree. I think you were very helpful last time.
All right. Well, thank you.
Yeah.
I didn't feel like it.
So after we've done the automatic recode, oh, never mind. We don't have to specify the groups in this. Did you say something, Sasha? Я полюблю это.
Ты будешь любить. Тебе очень понравится.
Что? А, наш ужин? То есть, да. О,
Я надеюсь, он будет вкусный, но это мясо пахнет вкусно.
русский?
Почти.
Okay.
Russian would be a cool language group to know.
It's pretty fun. It is very fun.
I was like,
She's we got some sausage the other day and she said it smells really good. It smells almost like Russian sausage, or I guess European.
Oh, really?
They have some great sausage over there. My goodness.
That's so cool.
Yeah, it's yummy. Also, another. What was that?
Yeah. I was just wondering if you could, like, can you knock at the same kind here?
I haven't been able to find it anywhere. It comes in like this long, it's like this long stick of sausage, probably. Well, it depends on what you buy, but they can be like this long or even longer. And
Okay.
wow, I miss that. You make so many good meals with it. Oh, where'd it go?
Very cool.
So another problem I had during the preparation was the degrees of freedom. I couldn't figure out where the preparation assignment, because I looked at the answer key after I did it, and I had totally the wrong answer.
Really?
Yeah, I don't know if
It's
I
just-
need to do something else.
It's two numbers. So you take the between groups degrees of freedom and the within groups degrees of freedom. So in this case, 5 and 114. So it'd be 5,
Same.
114.
Oh, 5 times 114?
Just 5, 114.
Oh, that makes so much more sense. I thought in the answer it was like 2,000 something, which seemed really large, but it's just, okay.
Yeah, it's just
that was 2
different
separate
numbers.
values.
Yeah, exactly.
Cool, okay.
Actually, that kind of confused me for a minute too in the assignment.
Oh, yeah.
Got it.
All right, so we're looking for the smallest variance here, the minimum.
Yeah.
Do we just pick the smallest number that's in the minimum column?
I assume so.
Because I don't know what to do for this.
So
Can you
I'm
smell
trying to
it?
remember.
Doesn't it smell Russian?
So would you take the square of each one of those numbers, and then the smallest one of those would be the minimum?
I very well could be. I just have no
Yeah.
idea.
Look at my notes one more time.
Okay. Sounds
I
good.
think that's what it said.
Yeah, it smells very Russian.
Or okay. Sorry, just give me 1 second.
You're fine. I'm looking through the textbook as well and see if I can learn it too.
So I'm actually
Ah.
thinking that it's the standard deviation squared.
Yeah, I just found this little green box. It says the variance is the square of the standard deviation. The sample variance is denoted by the symbol s squared.
Oh, sweet. Well, I guess now we know.
Yeah, so we take the smallest one of those in the list, I assume.
Yeah, the smallest would probably give us the, I mean, even squared, it'd probably give us the smallest.
Yeah, what is that? 5.216.
Which it looks like, yeah.
Cool. Okay, I got 27.207. Is that what you have?
Yep, that's what I got.
And now we're looking for the largest variance.
Okay. Okay, I got 53.159.
Yep, that's what I have too. 5.9. The test for the equal variance is satisfied for these data. So for this, do we just multiply the smallest one by 4?
Yep, I think so.
Just looking at it, it doesn't look like it would be.
Yeah, I don't think it would be. It should be a lot bigger.
Yeah. So I've got 108.828.
So,
Okay. So does that mean it's true or false?
so it needs to be less than or equal to in order to keep the null, right?
Yeah, I think so. So that would make it false then?
I think so.
Okay, cool.
Okay. So QQ plots.
See if I remember how to make that.
So,
Aha.
you remember?
Is it under descriptive statistics and analyze?
Yeah. Yep.
Perfect. And then I assume we do the kicking accuracy as the variable.
I think so. With the, yeah. I think so. Did I tell you my dad speaks Russian?
No, you didn't. How does he know Russian?
He majored in Russian speaking.
No way.
BYU.
That's awesome.
Yeah, he works for the translation department in the church.
Oh, that's got to be a blast.
Yeah, he's the international operations manager. So he just works with all the languages.
Uh-huh. Oh, that's so cool. Man, I would just love to work for the church, but as that just sounds like a lot of fun to me. Probably
Well,
stressful.
yeah, I'm sure it is.
Yeah.
So did you figure it out?
Yeah, I think so. Which one do we look at? Because the top one looks normally distributed. The one below that, I don't know if I put something in wrong, but it looks really funky.
Okay, let me see what mine looks like. So
Oh.
are you looking just at the normal QQ plots? Because the
Yeah.
other ones,
What was that?
the detrended ones are just, yeah, they're kind of weird.
Okay, that makes sense. I just looked at the name and saw normal. I thought, yeah, that's probably the one we look at. So this would be normally distributed, right?
Yeah, I believe so.
Cool. Perform an ANOVA test in SPSS and observe that the p-value is 0.081. Then remove the SOX data and perform the test again. What is the p-value when we remove the SOX data? That's interesting.
Okay.
So do we just go back to our data points and take out the last group, SOX?
I guess so.
Hmm.
And then just just run it again, I guess.
I think so. Yeah.
So,
Here. Oh.
which one is SOX again? Oh, it's just the bottom.
Mm-hmm. That's really yummy. Oh, wrong thing. Саша, какой будет p-value? Какой будет p-value? This?
0.309. Yep.
Huh. Okay. That's statistic. What's the p-value of the area to the right?
So the test statistic, go back. Test statistic is this.
Mm-hmm.
And so you have to plug it into that thing and then know if it's to the right, to the left, where you get that number. Does that make sense?
Yes. Into the applet.
Mm-hmm.
Interesting.
It's nice that she's taken that class before.
Crackers by itself.
Yeah, it really is.
Because it's,
What was
I
that?
think it's already cooked.
Well, what about it?
Because chicken crackers.
Do we have it?
No.
Yeah, I think so. Yeah, she's been able to help on a couple of things, that's for sure. Although she looked back and looked at her margin of error quiz questions. She got them right, but she couldn't remember when she was looking through everything how to get it. So, and I think she said that her group struggled with it as well.
Really?
There's just some that you struggle with because it seems like it's not in the book.
Not very clear
Yeah,
book and everything.
I know it. Were you able to get the test pulled up?
What was that?
Were you able to get the test pulled up?
The
The one without the socks?
yeah, I did it. Sorry.
Cool. No, you're fine. Did you get
Yeah.
0.309 for the p-value?
Yeah, that's what I just got. Yeah.
Okay.
You're cutting out every once in a while, so it's
Oh, I'm sorry about that.
no, it's fine.
Gotta love the internet connection.
Yeah. It's probably my computer. I have like 10 tabs pulled up right now.
So do I. Alright.
Okay, the test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or left the F statistic?
So,
I think it's to the right, right?
I
It's
think
the
so,
area-
because
Yeah.
what was that you were saying?
Oh, I was just gonna say it's the area under the tail, right?
Yeah,
So
I think so, under the right side. Yeah.
Okay. Is that what you were gonna say?
Yep. Mm-hmm.
Sorry. Okay.
Sure it is. All right, now we've got hot dog nutrition.
Sweet.
Okay.
Any luck pulling up your SPSS?
Just pulling it up now.
Okay. And mine's loading.
Okay. Looks like we have 2 data columns here.
Okay. Was the automatic recode already done, or was it just
No, it's not. We have to do that.
okay?
Yeah, and there are 3 groups.
Okay.
Recode. Okay. So while you're pulling that up, I'm just going to go ahead and read the background information.
Go for it.
It says, researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat, mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and their sodium level. Their data is available. Use the data for the remaining questions. Let's examine the calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumption to use ANOVA has been met.
Okay.
There's a lot to do there, geez.
Yeah. Okay. Okay. So would we just do, oh yeah, never mind, that's an easy question. It's an automatic recode for the beef and just the different types of meats, right?
Yeah.
I'm really grateful for this program. It makes this class so much easier.
Oh yeah. Can you imagine before this software came out? Phew.
Man, that'd be crazy.
Yeah, it sure would.
So when you're doing the one-way ANOVA, in the
Uh-huh.
variables would be the calories and sodium? Is that
So for this one, this question, we're focusing just on calories.
just on calories? Okay.
Yeah.
Awesome. Thank you.
Uh-huh.
So just to make sure I've done this right, have you pulled up have you run the ANOVA yet?
Yeah. Uh-huh.
Okay. Did you get your p-values being 0.283, 0.216, and 0.094?
For the p-value, I just have one.
You just have one,
And
yeah.
it's 0.000.
Hmm.
If I'm looking, is that the column that has SIG as the
Ooh,
title?
you're right. Yeah, mine's 0.000.
Okay. For your standard
also
deviations up top, do you have like 22.642 and 25.236?
Yeah, that's right.
Perfect. Yep. Got the same thing.
Okay. Good.
And
Sure.
this first question is, so we have to make the QQ plot and determine if the variances are equal.
Okay.
Рискотов.
So for this question, couldn't we just use the standard deviations and just to determine the variances from there?
Yeah. Uh-huh.
Okay.
So we just determine those variances. And then we have to create a QQ plot. We have to check both requirements
Okay. All right. I
for
did-
the answers.
Okay. All right.
Do you want some on a plate for me?
We're almost done. We only have about 5 questions left. So I'll just get out of the pan. Smells extra yummy. Oh, excuse me.
No, you good. Don't worry. All right. So, how are you doing over there?
So I think I've got an answer.
Okay. Me too.
The QQ plot that looked normally distributed to you, right?
In my
Okay.
mind, it-
So then I have B as an answer because it looks like it's normally distributed on the QQ plot, but the variances weren't equal.
I agree.
Mm-hmm.
But in order for them to be considered unequal, wouldn't have to be like, wouldn't the smallest one have to be 4 times, like when it was, okay, when it's added, like when you times it by 4, whatever,
Mm-hmm.
wouldn't it still have to be smaller then?
Right.
larger?
So I may not have done this part right. So I took 22.551 squared as the smallest,
Mm-hmm.
and then 25.236 squared as the largest. And for the smallest, I got 508, and the largest one, 636. And then if I was to have multiplied the smallest one by 4, I get like 2,000 something, which is larger than the large, excuse me, larger than the large, oh, wait a second. Oh, I
Yeah.
think I switched that up in my mind, yeah. So since it's smaller than the 4 times that, then we can assume that the assumptions have been met. Right?
Yeah, I think so. I think that's how I
Yeah.
had it made out in my mind. But
Yeah, and talking that out, I see what I did wrong there.
no, that's cool. I thought I was wrong, so I was working through it.
Yeah, no worries. So would that be A?
I think so. That's what I was thinking. But
Mhm. I think you're right. I'm pretty sure you are.
Okay.
Perfect. Oops.
all right. Well,
Did not need to push that.
if I'm wrong, then you're probably right. So
Well, I'm like 99.9% sure you're right.
all right, we'll see. Okay. So run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. The degrees of freedom are 2 and 51. The F equals 63.074, and that P equals 0.000. With the level of significance equal to 0.05, what conclusion can you draw?
Okay, so that's what we just did. I just double checked all those answers as you were reading them. So we don't have to do
Okay.
another test. This is what we already just did.
Perfect.
So 0.05 is level of significance, and p-value is less than that, meaning would it be the last one, D?
Yeah, I think so. Yeah, I was thinking C, but when you said that and I read through it, it looks right. I didn't even read through it. So.
Yeah, because we reject the null that they're all the same, and the alternative is at least one is different.
Yeah.
Perfect.
That's awesome. Thank you.
Yeah. All right. Now let's examine the sodium levels. Make a QQ plot. Okay, make a QQ plot. You should see that the QQ plot for poultry suggests a possible problem with the normality assumption. The smallest variance is 7,180. The largest is 10,492. Have the assumptions been met to use ANOVA?
Okay. So
Okay, make a QQ plot now. Что ты делаешь? Вкусно.
I'm making you feel jealous.
Okay, I think I've got it all created now.
Great.
Do you have your QQ plot pulled out?
yeah, I do.
Does that look normal to you? It looks kind of normal to me.
Yeah, I don't see anything weird with it.
Okay. I wasn't sure exactly what the problem was talking about with that part.
Wait, I'll look at it one more time.
You should see that the QQ plot for poultry suggests a possible problem with the normality assumption.
Okay. I wonder what that's referring to.
Where's your plot?
This right here. We don't have to do this test for each individual type of hot dog, do we?
I don't think so.
Okay, I don't think so either. Because then it wouldn't be an ANOVA test, I suppose.
Yeah, that's right.
Okay, so that's normal, and then 7. And then 4 times the smallest is larger than the largest,
Okay.
I think. Does that sound right to you?
I mean, it sounds right.
I'm gonna double check.
Yeah, I think you're right.
Okay. So does that mean that the assumptions have been met yet again?
Um, I think so. I think.
Hmm.
I think so.
Yeah. If that doesn't turn out to be the answer, then I'm gonna guess it's the one where it says the QQ plot is the problem, because that little weird snippet in the information. I don't know exactly what that was referring to.
Yeah. Okay, but you're probably right. Okay, despite the possible problem with the QQ plot for poultry, okay, so it probably was a problem. You decide to use ANOVA to determine if the mean sodium levels are the same for all three groups. So maybe we should go change that answer.
Yeah. All right.
I'm changing mine to B on that last one.
To be. But wouldn't it be, didn't we assume that the variances were equal though, and it was the QQ plot that was the problem?
Oh, yeah.
So would that be
you're right.
C?
Yeah, I think so.
Okay. And then we're looking for the p-value for this test. Is that the question? Yeah.
Yeah. Yep.
All right. Where is that?
My wife's brother just got back from his mission, and he just called.
Oh, no
Right.
way. I bet she loves that.
Yeah, she's pretty excited.
Where was he?
He was in California.
Okay, there you go. Was he Spanish speaking or English?
No, he spent most of his time with like Samoans.
Whoa.
He's like this big 300-pound guy. So
That's
It's good.
awesome.
but that was just English speaking.
Yeah, that's super cool. I've never been to California, but I've heard that it's pretty and expensive.
Yeah, those are both accurate.
For the p-value, did you get 0.179?
Yeah, that's what I got.
Okay, cool. Oops, not 179. There we go. And what conclusion can you draw about the mean sodium levels of the three types of hot dogs? Use a level of significance of 0.05, so we're not going to reject the null here, which means
Would that be A? I mean,
yeah, I think so. It's either that or B.
because the null hypothesis is that all the means are equal,
Right.
right?
Yeah.
If you don't reject it, then would that mean?
Yeah, I have a hard time remembering how we're supposed to write that out. So that sounds right to me.
Okay.
All right. Perfect.
I have a hard time with those. They're worded weird.
Yeah. I don't remember who went last, but I can go ahead and submit my quiz.
Okay. I already was like, wasn't even thinking about it.
Oh, you're already going for it?
Is that all right?
Yeah, that's fine. I haven't even pushed any buttons yet.
Okay. I should have told you.
No, you're fine.
Unless we got 100%, which would be sweet. And we got an 88.35%. So we missed the last one. I can see that. So that's my fault, probably.
So then it's probably B, right?
Yeah, what you were
Okay.
saying.
Okay.
And then 10, we missed 10. That one's an easy one.
And, oh, yep. I'll change that to true.
And then on question 4, it looks like those. So it's probably, I don't know, one of those probably isn't supposed to be marked.
Yeah, you selected all 3 of them, right?
Yeah.
Okay,
Yeah,
so
so-
then it's all except the top one.
Perfect. That's it.
Was that it?
Yeah.
Okay, not too bad then.
So I'm gonna open mine back up really quick. Could I
Sure thing.
get those answers? Actually, I should probably just write them down. But I mean, you're there, so it might be faster to just.
Yeah, no worries. Just whatever you want to do, I'm ready for it.
All right, question 3.
True.
True. 4 was just B and C.
Yeah.
Sweet. 5.
C.
6.
B.
7.
6.
8.
27.207.
9.
53.159.
10.
True.
11.
True.
12.
0.309.
All right, 13.
Right.
14.
A.
15.
D. Last one.
16.
C.
Jesus, this was a long quiz. 17.
Yeah. 0.179.
18.
B.
Okay.
I'm going to go ahead and submit mine. And there may be a chance that I had accidentally clicked the wrong one on one of the true and false. Oh, no. Okay, never mind. That's 100.
Oh, awesome. Sweet.
Feels good to get 100 again now that we don't have to get the margin of error.
That's true. Man, I wonder how we can figure that out.
I know that they have. Actually, I sit right next to a girl in chemistry who's taking biostatistics in class. I mean, on campus. I could ask her, and then if she doesn't know, I could always go to the math lab.
It's true.
Do you have a TA though?
And we have a TA. Yeah, that's right.
They're supposed to join
Yeah,
one of
that-
your groups at
that's
one
good.
point and help you.
Yeah, he has
I
an
think
email
he
to
did.
send.
I know, sometimes
We had to email
What was that?
ours.
I think I got an email from him.
Oh, really?
Yeah, so I might shoot him an email,
Yeah, for sure.
and I'll let you know what I find out.
Okay, sounds good. I'll let you know after tomorrow too.
Okay. Sounds good. Well, good luck preparing for that test.
Hey, you as well. May the small writing be with you.
Likewise.
Alrighty, see you
We'll talk
later.
to you later, man.
See ya.
Yeah, see ya.